Hi everyone, welcome back to the DS3 podcast. My name is Tanvi and today I'm here with Professor Emily Aiken. Professor Aiken's an assistant professor here at UCSD, jointly appointed at HDSI and the School of Global Policy. For the audience who don't know you, could you introduce yourself and tell us a little bit about how you got into the field? So I know you do research that involves using data science for humanitarian aid. So I kind of wanted to ask, what got you interested in this topic and how did you get started?
Great. Thank you for having me. Well, so I am Professor Emily Aiken. Like you said, I am a brand new assistant professor here at UCSD. So I'm half appointed in the Data Science Institute, HDSI, and I'm half appointed in the School of Global Policy and Strategy, which is an appointment that really reflects my research and my research interests. So I do work on using data-intensive methods in development economics. So especially using data-intensive methods for questions related to social protection programs and humanitarian aid programs and the measurement and targeting of poverty. In terms of, I guess, how I got into that kind of work, I think often when it comes to sort of data-intensive research, you have people coming either with like really strong background in sort of the methods in data science and computer science, or people coming more from like a really strong application background. I came more from the computer science side, so I did my bachelor's in computer science, and then and that was kind of when the field of data science was getting started, really. Mm-hmm. But then I always wanted to use that for something that would be sort of more, I mean, I have to put it in quotes, but like socially good or somehow bring hopefully good things into the world. And I was always really motivated by questions related to poverty and just improving socioeconomic status, and wanted to find a way to sort of use my computational training towards trying to, do a better and better job with anti-poverty and development and humanitarian aid programs. Mm-hmm. And was super lucky to end up doing a PhD really at that intersection. So I did my PhD at UC Berkeley in a very small department called the School of Information. And there I sort of got really into this niche intersection between data science and development economics, and also just built up a lot more of that application expertise when it comes to development economics.
So cool.
And so that's how I ended up here. And then I guess the last thing I would say is that in the last 2 years, I finished my PhD at Berkeley 2 years ago, and then spent 2 years living in Rwanda, in Kigali, at Carnegie Mellon University, Africa, as a postdoc, where I did, the same kind of work, sort of computer science for development, and now I'm really excited to bring that kind of work to UCSD.
Oh, that's so amazing. I kind of wanted to ask about the School of Information and information science in specific. How would you say it kind of differs from your undergraduate training in computer science, like in the disciplines you go through?
Yeah, it's a really good question. And I think in a lot of ways it's actually pretty similar to what we're doing in the data science department here at UCSD or in the Data Science Institute. The School of Information at UC Berkeley and sort of other schools of information around the country and around the world tend to focus on sort of research at the intersection of technology and society, but take a very interdisciplinary approach to that intersection. So I had people in my program, like faculty and PhD students, who were economists, who were computer scientists, who were sociologists, people doing qualitative research, people doing very computational research, legal research. So like really just people from a lot of disciplinary lenses. And I think, I really appreciated that interdisciplinary approach, and sort of not, disciplines often have very sort of strict practices in how they look at things, and it was really nice to take a step back and say, okay, I really care about this problem, I care about poverty, but not having to worry about like what's the discipline from which I'm going to approach that problem. And I think we have some of that here at UCSD, in the Data Science Institute, in the Design Lab. Like there's spaces that are also kind of creating that interdisciplinary approach in the School of Public Policy as well, for sure. Mm-hmm. And I definitely like to also bring that here a bit, because I'm much more motivated by the problem than I am by any particular method.
Mm-hmm. That's really exciting. And I know, data science is like inherently a very interdisciplinary field. So it's amazing that, we get to talk to people who have expertise in so many different backgrounds using data to support that.
Yeah.
Mm-hmm. I also wanted to ask a little bit about your experience at CMU Africa and, the kind of work you did there, like the kind of research you were working on.
Yeah, so CMU Africa is a campus of Carnegie Mellon University that's located in Kigali, Rwanda, and that's where I was doing my postdoc before I came here to start the assistant professor position. And there I really sort of continued my current research agenda. I sort of have a research agenda that started my PhD and continues until now, which is mostly focused on how best to design aid programs. And so, for example, in Rwanda right now, I work with Give Directly, which is a big nonprofit, US-based nonprofit, but a lot of their operations are in East Africa, and they do direct cash transfers. So their programming is that they raise money and then they give away cash to very poor households. Of course, their principal challenge is how to find those very poor households. And so, for example, in Rwanda right now, I work with Give Directly on the targeting of that particular cash transfer program, as well as some kinds of sort of algorithmic explainability research around then how do we explain eligibility criteria to the communities that we are providing cash transfers to. So that's one of the things I worked on in Rwanda. I also worked quite a lot with the government there. So a lot of my work, as you can kind of tell, is in partnership with sort of either governments or NGOs, policy partners that are implementing real world data-driven aid programs. And so I also worked with the government there, which is transitioning its approach to running its own aid programs, which sort of are various different types of aid programs, cash transfer programs, but also public works programs where people get to have guaranteed work and guaranteed pay for some days of the year. And they were also in the middle of really transitioning how they decide who is eligible for those programs and taking a more data-driven approach. And so I've also done quite a lot of work with them and with the World Bank on that while I was there. So that was really great. Right now, besides Rwanda, I also work a lot in Malawi and in South Africa. And so I'm really excited to kind of bring these Sub-Saharan African partnerships here and get to continue building that research agenda.
That's amazing. You kind of had that thread with you through your PhD and then your work after, and now you're able to bring it to UCSD. I saw that in your research, in your papers, you've looked a lot, in algorithms, community knowledge, surveys, etc., to kind of be able to figure out who needs aid the most and how should they receive it. So I kind of wanted to ask, is there anything from your research that really surprised you? And, is there a difference between the findings you've done across different methods?
Yeah, okay, that's a big question. Maybe I can just briefly describe kind of what my research looks like and then try to answer this question about surprises, of which there have been many. But so, I mean, in brief, as I've said, I work on thinking about how best to allocate aid and humanitarian aid or social protection programs. You can think about, for example, cash transfer programs that just give money and you're really trying to identify the poorest people to provide that money to. And the reason for this is because typically there's not enough budget in an NGO's budget or in a government's budget to provide aid to everybody. And so while we would like to think about something like a universal basic income, in practice, usually there's not enough budget that everybody can actually benefit from a program. And so we want to make sure that it's targeted to the people that need it the most. Then the problem is, how do you actually do that? In high-income countries, very often that's not too difficult of a problem. It's still not perfect, but we typically have pretty high-quality data on people's incomes or level of poverty based on administrative data from tax returns. So in the US, every year we submit a tax return. From that, the government has a pretty high-quality verified record of our income. Again, not perfect. Not everybody submits tax returns. Not all of them are complete or accurate, but it's pretty reasonable. In low-income countries, very often that kind of data isn't available, basically because, one, often large shares of the workforce are either informally employed, so they're not paying taxes, or they're just working in subsistence agriculture. They're just farmers, and so they're, again, not paying taxes. And so we don't have that kind of admin record of income. And then, you could hypothetically go like household to household and do a full poverty census, but typically the lowest income countries also have the lowest capacity for such data collection. And so as a result, we almost never have that kind of comprehensive poverty census available. Well, what do? A lot of what I work on is trying to basically fill that data gap with whatever data we can source that is comprehensive and accurate and up to date. So I work a lot with satellite imagery, the intuition being that we can see from a satellite image a lot of information about a household. We can see what the roof material is, how big the house is, information about the surrounding cropland, road quality, forest cover, access to water. All of that is in the image. It's just a matter of taking that fairly unstructured image data and turning it into an estimate of poverty. And that's where the data science comes in, right? That's where the machine learning comes in. So I work a lot with satellite imagery. I work sometimes with mobile phone usage data. So how much people are using their phone, like how much airtime they're using or how much mobile data they're using can be highly correlated with poverty. Right now I work also with financial data. So information from banks, of course, can be very predictive, or mobile money transactions. I work with that in Rwanda and in South Africa. Also just government administrative data. So information the government might already have on like property registries, vehicle registries. This can also be really useful. So we're really just trying to, I guess the data science mindset is like, what data is available? What do we have consent to access? How well can we approximate poverty from that type of information, and what methods are helpful? And also I think, how can we refine those methods? And maybe that's what I'll say in terms of a surprise. Like I said, there have been many surprises, but most of my work is really motivated by these specific policy problems. Like the government of Togo comes and says, we have these types of data, we want to infer who we should give a cash transfer to. Like that's a lot of what motivates my research. One thing that's been surprising is that very often I've found that these sort of specific policy problems that I work on motivate innovations in data science methods that might be more broadly applicable. So especially because I work in settings often where there's very low quality data, it's often very sort of sparse but high dimensional data. So these types of like time series of mobile phone use or financial transactions, very sparse, but like very high dimensional, very rich in their own way. That's going to drive innovations in how we handle that type of data that then might be useful to data science more broadly. So just as an example, like one thing I'm working on at the moment is thinking about how data decays over time. Like a big problem we have in measuring poverty is that poverty is highly dynamic, and we need to have measures that actually are able to capture changes in poverty over time. And traditional data from surveys, if I go and do a survey today on a household socioeconomic status, that's not going to last that long. Like they can change socioeconomic status over time, right? And so we're doing work on sort of how do we build estimators of poverty that are robust to this data decay over time. And that's not something that's been thought about so much in the data science literature. And I hope it's something that can be useful not just on poverty, but to other settings where we can think about kind of data quality going out of date over time. So that's one surprise, and it's been sort of a good surprise that the policy questions motivate these real methodological innovations. There's been other surprises, not all of them is good, but that's a more positive one.
Yeah, absolutely. I think that's honestly so exciting, and getting to work with so much unstructured data that it's like a lot of our classes, as undergrads, we work with a lot of structured data and how to handle that. But, working with unstructured data is a lot more complex, and I'm sure it comes with a lot of its own nuances and surprises. A lot of your work, as you've said, relies on, collecting what data is available from places like, Togo, like I think Bangladesh as well. So I kind of wanted to ask you about how that collection process looks like, and how the data you use kind of varies from place to place.
Yeah, it's a great question. Most of my projects are sort of place specific, very often, again, in collaboration with either a government or an NGO partner. And so originally, I wrote my dissertation mostly in the West African country of Togo. I did some follow-up work on that in Bangladesh, and now I work in Rwanda, Malawi, and South Africa. And so, it's often just sort of based on where there's policy interest or government interest in this type of thing, where there's funding, and then, of course, where the data kind of makes sense. So certainly my work is most relevant in settings that are sort of lowest income, highest data scarcity. And so, for example, I don't see a ton of application of my work in Norway. I would actually love to work on social protection in Norway at some point, but for the most part, my work is centered in the lowest income countries, and especially in Sub-Saharan Africa. To your question about what data we use and how that varies from place to place, yeah, so what data makes sense and is available tends to vary quite a lot from place to place. So for example, in Togo, in my PhD dissertation, we worked very closely with the government and also with the mobile network operators, the phone operators, because in that setting, we were working during the COVID pandemic and basically trying to help the government very quickly roll out an aid program to offset the economic downturn associated with the pandemic. But they couldn't do their normal way of deciding who would receive that aid, which would be to send people into the field to go and do field verifications of poverty. And so we were trying to spin something up that would not require in-person interaction with people who were applying for the program.
Mm-hmm.
And we ended up working very closely with both of Togo's 2 mobile network operators who provided us anonymized information about how much each mobile subscriber was using their phone in terms of, how many calls, how many texts, how much mobile data they were consuming, measures of mobility based on what cell towers were used, and so on, and then training machine learning algorithms to predict based on that whether people were wealthy or poor. So that's one type of data, and that was the main thing we relied on in Togo. Just to give a couple other examples, in Bangladesh, we looked into phone data. We also worked with the mobile network operators in Bangladesh, but we also worked with communities and tried to compare how the sort of algorithmic approaches compared to community-based approaches. And the idea here, and this has been studied in some other contexts, and primarily in Indonesia, but we worked on it also in Bangladesh, is that sort of local information might be very helpful, right? We can take all of this sort of big data, this passively collected digital data, but it still doesn't give us the same level of information that people on the ground are likely to have. So in Bangladesh, we worked on these community wealth rankings. We would talk to members of the community about who in your community is most in need of aid. And then we also worked on preference aggregation or approaches to basically get these kind of decentralized measures of who is most in need of aid from each neighbor and then aggregate those rankings together.
Yeah.
And then I can just say really briefly, just as another contrast, I currently work on some research in South Africa where we're focused more on the South African government already has an aid targeting system that relies on working with banks and looking at bank transaction volumes as well as other administrative data from the government. So we're working with them on refining how they use those data and sort of making more sophisticated use of predictive modeling to use those data to allocate aid.
Absolutely. What kind of, models and techniques do you primarily use in your work?
Yeah, so, a lot of it's just really basic supervised learning. So I think something that's nice is that a lot of what we do, especially when it comes to the more tabular data sources, looking at number of transactions on the phone or looking at whether a household owns, a car as they reported in a survey or things like this, it really is just the kind of tabular data that you would see in your 3rd year supervised learning class or whatever it is, right? So a lot of it can be fairly straightforward out of the box supervised learning. We do, and I think some of the sort of more methods of innovation is also thinking about how to better leverage structure in the data beyond just sort of standard tabular data. So as I mentioned satellite imagery at the beginning, obviously this is a really good use case for supervised learning models, for computer vision models. And then some of the phone data work I do, that's also got a lot of really interesting structure. It is a social network, right? Phone data, we're making phone calls to each other, that creates this social network. It's also spatial, it's also temporal. And so thinking about neural network architectures that allow us to leverage that kind of structure in the data has also been a really fruitful way to push the boundaries of the field. And then I guess the last thing I'd say is, of course, these days we're also all thinking about transformer models and how to take kind of the next token prediction to produce embeddings paradigm and then bring it to the types of data I work with. So phone data, financial data, how do we think about generating meaningful embeddings of those types of data that then can be useful for multiple downstream tasks is of course, that's what we're all thinking about at the moment.
Absolutely. And I'll ask a little bit more about, the latest advancements and how you think that would, that affects your field of research.
Yeah.
But I honestly think it's so amazing how a lot of the work you do has such a real impact on, all of these communities. It's almost it's very time sensitive, as you were saying, about COVID, and, governments need solutions immediately. It's not something that can wait. So honestly, that's really admirable. And yeah, so I kind of wanted to then ask you about another one of your projects, which is Cider, which I've read is an open source library that kind of uses phone data, as you said, to target poverty. So I read that it worked really well in Togo and helped kind of reduce errors of exclusion by 4 to 21%. But have you seen it used in any other situations? What applications do you see for Cider going forward, and how do you think those will play out?
Yeah. So this was the project I was mentioning earlier in Togo during my PhD. We worked on using mobile phone metadata, so information about phone usage, to predict and target people living in poverty. And basically, so that was the first time, to my knowledge, that such approaches have been used in practice. Like prior to that work, people had worked on this sort of in research and theory, but it was the first time that that a government actually used this approach to actually distribute a cash transfer program and Give Directly, and then the government of Togo together distributed, I think, something like 200,000 cash transfers during the pandemic based on this approach. And sort of as soon as once we had made progress on that project, it was pretty clear that there would be interest from other stakeholders in taking similar approaches. And so I basically took like a summer of my PhD and wrote this kind of software package that would allow replication, though I cannot claim to be a good software engineer. And so I'm sure users of this package would have all kinds of thoughts on whether it really qualifies as a software package. But anyway, we put together like a body of code that is fairly replicable for this. And we have seen other entities use it a few times. So the World Food Program used a similar approach in Haiti. Our biggest kind of like user, really our biggest partner in this space, is this NGO Give Directly, which has used this approach in a couple different settings. I mentioned Bangladesh, I mentioned Malawi. Also something quite similar was done by the World Bank and Give Directly in the Congo, also back during COVID. And so we've seen, some kinds of take up of this approach. I think, and sort of to your comment about like, okay, it reduced errors of exclusion by X% or something like that, really whether or not it makes sense to use this approach and whether this approach is going to be a good one in a given setting depends on sort of what the outside option is, right? So like if there's already really good data in a given country and like recently collected data on poverty on a sort of full poverty census that was conducted last year, like I'm not going to tell anybody that it would be better to go and use an algorithm on phone data. I would say, much better to use your high quality in-person data you collected on poverty. But in settings like the COVID pandemic, for example, or if there's a really big environmental shock or a conflict, in settings where it's really hard to go and collect traditional in-person data, those are the settings where turning to something like phone data and something that can be a bit more dynamic and responsive really makes sense. And so I think we've seen some take up in those kinds of settings, like Haiti being a really good example. But I'm not saying that this is like the be-all and end-all solution by any means for every setting.
And absolutely, you've talked a lot about, different governments having different needs and priorities, and, your research is tailored to, those kinds of the communication you do with these governments. So, you mentioned the cash transfer program in Togo, and I kind of wanted to ask a little bit more about, what the process of collaborating with the government on, that scale, how did that look like, and where did you find yourself, like, with the most challenges?
Yeah, it's a great question. It's like actually quite a lot of what I do kind of on the day-to-day is more of these building partnerships with governments and sort of working really closely with them to figure out what are the constraints, what is the thing we're trying to optimize for. So I think it's a well-placed question because so much more of what I do is that rather than, doing fancy data science, if I'm honest. So what does that really look like? Well, I can give you the example of Togo as maybe quite a good example. In that case, and this very rarely happens, but it happened in this case, they actually had somehow learned about some work I had done with my PhD advisor previously, just showing kind of in simulation that you could predict poverty from phone data. I mean, that was some work we did in Afghanistan. And they had, I don't know how, but they had learned about this work and actually read some of it and basically wrote to us and they said, we really want you to come and do this with us during the pandemic. This was the very first year of my PhD, so it was pretty crazy that they wanted to go and do this in practice. And I think in that case, and really in all the cases I can think of, we were lucky to work with extremely motivated, extremely dedicated public servants who really just wanted to build out the best program they possibly could to help as many people who were really in need as they possibly could. And so working with like extremely effective, dedicated policymakers has been probably the best thing about my work to date. And in that case, we worked very closely. It was the Ministry of Digital Innovation in Togo that was running that program, and we worked very closely with the minister as well as some of her staff. And I think one thing I definitely learned is like, these people are super smart, like very, very good at what they do, but aren't super technically trained. And so they're not like, they didn't do degrees in data science. And so you also learn a lot about kind of communicating algorithmic decision rules in like as simple a way as possible to try to explain like, yes, we have this machine learning algorithm running in the background, leveraging these different types of data, but trying to break that down into this is really why someone is eligible and somebody else isn't, like this is how this works. And so I think there's like some really interesting kinds of explainable AI that need to happen there to make that possible. So actually that's one of the things I'm interested in at the moment is kind of this like last mile AI explainability, both for policymakers, but also for the communities that these algorithms are predicting upon. But anyway, in the case of Togo, we worked with them over about 2 years, basically over the whole life cycle of the project, from like conceiving of doing this to helping design the cash transfer program. We also piloted a bunch with them. We even helped pilot the like registration platform for people to register for cash transfers, all the way to evaluating how accurately this worked. And so the sort of research component of that project was running a big survey, which then allowed us to say, okay, who was really poor? Which of the poor people did we reach? How accurately did we identify the poorest people? And we really just had great support from the government, like throughout that entire life cycle. I spent like quite a lot of time in Togo during that project over a few months, and in subsequent projects I've also spent like quite a lot of time in in-person collaborations, and I find those really helpful. But all that is to say, like these kinds of collaborations are absolutely one of the greatest things about the work I get to do. And I think I would also, given that this podcast is mostly for students, say, you know, I think the career paths that are salient in data science are very often like tech, consulting, this kind of thing. Government is probably where you can make the biggest impact with data science skills. And a lot of the time I'm kind of doing that as an outside researcher, but more and more there's demand for really good data scientists in government. So I think that's an outside career path that might be worth considering.
Yeah, that's honestly amazing. And I know, as the field evolves, data science is kind of becoming more and more about, understanding the domain you're working in, especially in something like government, where I guess it's really amazing that you're, I guess, a joint professor in 2 different departments, because you can really speak to the bridge between these two. And I think that's amazing for anyone who wants to go into the field. So I kind of wanted to ask a little bit more about, so now you're a professor here at UCSD, which is so amazing. So I wanted to ask about any prospective classes you have that you're planning on like either designing or taking up. Could you speak a little bit about that?
Yes, yeah. So as a joint professor, my teaching is split between data science and public policy. Public policy is only a master's program, so probably for students who are listening to this podcast, maybe not as relevant, but actually if you're thinking about doing a master's, it's a really great master's, but for now, that's probably not as relevant. In data science, I will teach 2 courses. This coming year, I will teach a course on data science and development, so very much my research field. So if you're interested in how data science can be used in development economics, as I was speaking about now with my research, or just more generally kind of data science for social science, I would really encourage you to take that course. There's not so many social science faculty at HDSI, and so I hope that this will be a course that's really interesting to any students that are interested in bringing more data-intensive methods to the social sciences. I think that's going to be offered in fall quarter, as far as I know, but stay tuned. I think the course number is 190. I will also teach a second course, but that is to be decided what that will end up being. So for now, the one that's confirmed is the data science for development.
That's so amazing. I think it's definitely something that I'm actually going to be a master's student soon, so I'll keep a lookout for the global public policy classes you had as well.
And the data science one is actually available to both undergrads. It's like a joint 190, 290, so
oh, wait, that's so cool.
You never know.
That's amazing. Yeah. I also wanted to ask more. So, you plan to teach classes that are in the intersection of data science and, public policy. Also wanted to ask, a lot of people in data science are interested in work that has high impact and has potential for social good. So I kind of wanted to ask, what do you think this path would look like for somebody who's currently an undergrad and interested in getting started? And, what kind of skills and tools could help that you might not find just in an undergrad data science degree?
Yeah, that's a great question. I love that question. Thanks for asking it. In terms of what the career path will look like, and then I can come back to this kind of tools question. Yeah. In terms of career paths, I think if you're interested in going into more kind of public service or sort of impact-oriented type roles, government is of course an option, NGOs are of course an option, so are sort of bigger multilaterals, so thinking about for like the World Bank, for example, or the UN. What's been really cool to see, I mean, to be honest, one of the reasons I went into academia, like when I started my PhD, was that I really wanted to do this work on data science for development, but as far as I could find, nobody was hiring for that in sort of industry or in the real world. And it wasn't that I was so motivated to do a PhD, if I'm honest. It was more that I really wanted to do that kind of work, and the only place I could see it being done was academia. Mm-hmm. And that is just not true at all these days. These days I see all the big NGOs are hiring for data scientists. The World Bank is hiring a ton for data scientists. So if you're sort of teched up on the data science, then have some knowledge of the application, I think you're very well positioned for that kind of job. And then, so that sort of brings me into this question about what would you maybe want to do now. I think, and it's kind of a classic piece of advice that you get if you're doing data science, but to the extent that you have elective options, I would say trying to focus those electives towards something kind of in the domain you're trying to do. So if you're really interested in, working on, let's say, environmental stuff, making sure that you take enough classes, or maybe ideally do like a minor in environmental science or something like that, so that you have some of that domain expertise, right? Or similarly, if you want to do public health, like that's another area where you can do data science with really high impact, go and take some public health classes. If it's development, go and take some global development classes. So, I mean, it's kind of the obvious advice, but getting some amount of that domain expertise is extremely valuable, so you don't end up walking into the World Bank as a data scientist who has no idea about anything to do with poverty.
Yeah, I think that's really amazing advice, and I think a lot of data science students try to, I guess, minor in something that aligns with the domain that they want to, work in. Like I know a lot of data science students with like kind of like biology minors if they're interested in like bioinformatics, or something like more business related if they want to do business. So I think that's amazing. Does the School of Global Policy have any minors available? Do you know?
Oh my gosh, this is this is an important question. There is no minor offered at GPS, but there's a related undergraduate program called, I'm gonna forget it, but I think it's like the international relations, something close to international relations, which I believe you can major or minor in, and so that could be a good one. And that's GPS public policy school faculty do teach in that program, and so you would have the opportunity to take classes with GPS faculty.
Yeah, that's amazing. Yeah, definitely keep a lookout for that if you're interested. And then I kind of wanted to ask a bit more about where you see the future of global policy heading. I know you were mentioning kind of using AI for like explainability in terms of like policies. So I kind of wanted to ask, like, with these new rapid advancements, where do you see your work as well as the broader field of data science in public policy heading?
Yeah. I mean, so certainly advances in generative AI in the last couple of years are pretty quickly changing the type of work that people do in my field. And there's many funding agencies and research projects now that are focused on the impact of generative AI in development. And I mean, just to give a few examples, a lot of that is around, tutoring for sure, so sort of personalized tutoring in settings where there's not good resources for the education department can make a really big difference. Work on, like early detection in healthcare, AI support for community health workers in settings where the healthcare system is more kind of these community health workers who are serving villages rather than having medical facilities available to every single community. So I think there's like a lot of potential for generative AI in low-income settings and in these specific areas in education and health and so on. In terms of, I think, how this affects my particular kind of work, or moreover, maybe kind of like my sort of cautionary thought on this is that a lot of the settings I work with still are pretty just low tech in general. So like in Togo, when I was working there, it's probably changed a bit now, but like back in 2018 when we were working on this project, I think 65% of adults had access to a phone. That wasn't even like owning a phone, it was like there was a phone in your household. And so there's still 45% of people that just didn't even have a phone at all, right? Or like now in Rwanda, I think, phone ownership is or phone access is pretty ubiquitous, but many of those phones are still feature phones. They're not smartphones. So these are phones that can only send calls or send text messages, not access the internet. And so when we think about like the transformational power of AI in low income settings, I think there's still a lot there, but we need to think about these sort of basic digitization constraints. And there's a lot of evidence from research basically showing that when you try to just bring tech in to fix everything, it's really not going to work that well. And I think a really good example is like the famous example of one laptop per child that tried to bring computers to low-income villages. I think it was mostly in Latin America. And like famously, everybody thought these computers were going to totally revolutionize education when you didn't have a lot of resources for teachers. But in fact, what ended up happening is that computers broke. There was no facility for repair. People didn't know how to use the computers. And so there's like just basic digitization constraints that probably are going to be really important as we think about what AI can and can't transform. And so still thinking about just designing interfaces for people to kind of fill that last mile. I think a really obvious example is if we see, Gen AI in really low income settings, probably thinking about voice first Gen AI, where this is happening over a phone interaction rather than having like a chatbot based interface is going to be much more useful in settings where there's low phone access, low literacy, low digital literacy. And so I'm not questioning the transformational power, but rather thinking that we really need to learn from the past and sort of the extent to which technology has or hasn't been able to break these kinds of barriers in the past and try to design Gen AI solutions that account for the specific setting that they're going to be deployed in.
Yeah, that's amazing advice. And I feel like you can kind of see that across industries where a lot of times they kind of shoehorn AI into spaces where a much simpler solution could, be more relevant. So I think that's really important to keep in mind. And then as kind of a last question, I wanted to ask, so you're new to UCSD. What's been your favorite part about, San Diego or about UCSD in general since coming here?
Lots of good things. I'll list two favorites. First favorite is my colleagues and my students. I think it's been great. Like I am in two really wonderful departments in public policy and in data science, both of which are really interdisciplinary people doing all kinds of super cool work. And then, of course, the biggest joy of being faculty is getting to work with students and teach and work with PhD students. And so that's also been really wonderful. So far, I think that UCSD students, as I've seen it so far, have a really nice combination of being, smart and motivated, but also not like really crazy intense. So a nice mix. And then the city, San Diego, surfing. Definitely, like access to surfing is really great here. That's been awesome.
Well, thank you so much for joining us and sharing about your research as well as potential career paths in the intersection of data science and policy. It's been really amazing having you. Thank you so much for listening.
Cool. Thanks for having me. Thanks for listening. Take my class in the fall.